Hey, Matthew, Chase, Michael, good Monday to you. Monday the 29th. Hope you guys are working hard on your videos. By the way, it is your job to call me or email me if you're having problems. That is your job. When we come into class on Thursday, I will not be reteaching anything, okay? I've worked the homework out for you. I've given you notes. And that's why I've done all that test, all of that stuff. Excuse me, Chase, Matthew, you guys owe me a test and a quiz on Thursday. If you do not turn in on Thursday, you will lose points. I will let your parents know, so please get those turned in. If you have questions on those, email me or call me before Thursday. Let's see, test, Chase, your test is graded, by the way. And when I send your mom the progress reports, it's on there. So you're welcome to look at that. You will go over it on Thursday, and I'll show you what you did wrong. But just letting you know about that. Okay, you should have printed your handouts. If you have not done that, then pause the video and print your handouts. And let's move on. We're going to review just one thing from Friday, and there it is. We learned how to graph logarithmic functions. Give me just 1 second, please. I'm going to talk to my daughter. Jessica, would you bring me the graphing calculator? It's in the bedroom, in Michael's room. Thanks. Sorry about that, students. Anyways, we're going to graph this. This is a review from Friday. And so, first of all, you're welcome to watch me do it and not get, I'll count this as a full bonus point. So you're welcome to watch me do it and not get the bonus point, or you can pause the video now and try to do it on your own. If you get it right, get a bonus point. That's totally up to you, okay? All right, here we go. This is review from Friday. Step one was find the vertical asymptote. Now, first of all, the argument for the logarithm would be x minus 4 if there's parentheses around the x minus 4. There's not, so the argument is just x. So step one in Friday's notes said find the vertical asymptote by setting the argument equal to 0 and solving. So we take the argument, we set it equal to 0, and we solve. Well, there's no solving to do. X equals 0, so your vertical asymptote is at 0. Okay? Step 2 said type this into your grapher and then fill in a table of values with your vertical asymptote up top. So here's how you would type this into your grapher. You hit y equals, then push the number 3. All right, then push log, and when you do that, a parenthesis should pop up. Now, this is not a base 10. This is a base 4. Now, if it was a base 10, we could just type the whole thing in and be done with it. But it's not a base 10, it's a base 4, so we have to use the change of base formula, in which we type in 3, then log, and then x, and then close your parentheses, and then hit the division button, and then hit log again, and when you do, this parentheses pops up, and then type this 4. I'm circling it, this 4 right here that I'm circling. You want to type that in, and then close your parentheses, and then minus 4. That's exactly how you should type it into your grapher, and I've already got typed in here unless someone cleared it out, and someone did clear it out. My son must have been doing his homework. So let me very quickly type this in. Sorry about that. So 3 log x, close the parentheses, divided by log 4, close the parentheses, minus 4. All right, now your table of values should say error. First of all, let's come to your table of values. You should have a 0 right here. You always start with your vertical asymptote. And if you'll look in your computer, your calculators, it should say error. And then notice -1 and -2 are errors also. So you don't want to go to -1. You want to go to 1, 2, 3, 4. Now, if you've typed this in correctly, 1 gives you out a -4. 2 gives you out a -2.5. 3 has an output of -1.623. And 4 has an output of -1. All right. Now, we learned all of this Friday. Now, step 3 said sketch your graph or draw your graph. However, don't forget to put your vertical asymptote on your graph. So I'm going to sketch this very quickly. I'm not trying to win the neatness of the year award or art of the year award. So here we go. Table of values. Here's your coordinate plane. And the first thing I would recommend that you do is put the vertical asymptote on the graph. Give me 1 more second, please. There we go. All right, your vertical asymptote is at 0, so I'm going to put a dotted line going right through 0, which of course falls on top of the y-axis. So there's your vertical asymptote. And now, point number 1 is 1, -4. So I plot that point. The next one is 2, -2.5. and the next one would be 3, negative 1.6, and the next one is 4, negative 1. And we know it's a curve, not a straight line. We know that. So we'll kind of sketch it like this. I'm not that picky about your sketches as long as your table of values is correct and as long as your vertical asymptotes are in the right place. I'm okay. All right. Now let's talk about domain and range. Okay. Now I did not ask you to do domain and range for a bonus point, so if you didn't do it, relax. As long as you got the graph right and the table of values right, give yourself a bonus point. Now let's continue on. Domain deals with left and right behavior. Do you see any boundaries that would stop the graph from going left or right? Well, sure. Right here is the boundary. I'm going to make it really dark for you. Here's an asymptote, vertical. It's cutting this thing off from going this direction. It cannot go that way. All right? The only direction it can go is this way. The graph has to stay over here. Well, that's to the right of 0. Remember, your vertical asymptote is at 0, and you have to stay to the right. So if you have to stay to the right, then obviously my domain's going to be, let me break out the eraser here. Obviously the domain's going to be x is greater than 0. Now if the graph would have been over here on this side, then I would say x is less than 0. But that's not the case. All right, now let's go to the range. Do you see any boundaries? Range is the up and down behavior of the graph. Do you see any boundaries that would hinder this graph from going up or down? I see none. As it moves more and more to the right, it will gradually get higher and higher. We can see it continues going down and down. So the range is going to be all real numbers. All real numbers. All right, so that's a quick review problem. I hope that helped, and let's get started with today's notes. If you'll grab your handout, you should see up top it says we're going to graph logistic growth functions today. Graphing logistic growth functions. And so if you'll look at your notes on the first page there, I'm not sure of the page number, 70 something, I think it's 77 or 78, but I'm going to read these to you. First of all, it says, here is the model of a logistic growth function. If you'll look at your notes, you'll see this right here. I'm going to write it really big for you to see. Okay? You might want to look at the screen. I'm going to make it bigger because I'm not so sure that your notes are really legible. This exponent is negative Rx. Negative Rx. Now I'm going to change colors and draw some arrows. It's really important that you're familiar with this model because we're going to talk about C, we're going to talk about A, and we're going to talk about R. Remember, E is a number. Don't ever forget that. E is like pi. It's a number. Okay? But we're going to be talking about C, A, and R when we start graphing these in just a little bit. Okay? All right. So with that in mind, let's continue on. So this is the model of a logistic growth function, okay? I'm going to read the next sentence. You follow along. You need to be familiar with this model because we will be using A, C, and R in formulas to help us graph these functions. Next sentence. You need to know also that these functions have 2 horizontal asymptotes. Not 1, students, 2. Here's a picture of what the graph looks like down below. Now, I don't think you see anything on your paper. I left it blank. I want you to go ahead and draw this, okay? So, in that space provided down below, go ahead and quickly draw a coordinate plane. You don't need tick marks. Let's do it really fast, okay? Now, let's go ahead and throw a horizontal asymptote at 0 like this. So there's a horizontal asymptote at 0. And let's throw a horizontal asymptote up here. I don't know, that's around 5 or 4. It doesn't really matter, okay? We don't need tick marks. It's not a big deal. All I'm trying to do right now is just show you basically what the graph will look like when you graph a logistic growth function. It'll look like this. It'll have a middle value here, and we're going to talk about that later, okay? And it's going to come up and curve and kind of narrow out. Come down and curve like this. So somewhere in your notes at the bottom of that first page, I've left you a little space. I want you to go ahead and draw a picture of this graph. Now, you know from past experiences, this graph might be wider, narrower, it might be flatter, longer, whatever. It might be over here. It might be here like this and like this. But the basic shape is going to remain the same. It'll look something like this, and there will be a double horizontal asymptote. Okay? So far I've given you the model. There's the model, and now I've given you a picture of what the graph looks like. So let's go ahead and continue on. Notice in your notes today, I've only given you one problem that we're going to do together. And the reason for that is because I really feel like they're not that hard. You just need to practice. And so I'm going to get you pointed in the right direction, and then have you practice 5 homework problems that I feel will be really helpful. Okay. All right. Now, if you'll go ahead and glance at the top of your next page of your notes. Remember, I go fast on purpose because you can always speed the video up, but you cannot slow it down. Excuse me, I said that backwards. I apologize. You can never speed the video up, but you can always slow it down by pausing it and rewinding it. So I'm going to move on. Look at the top of page 2. You're going to see 4 steps for graphing logistic growth functions. Step 1 says, find the 2 horizontal asymptotes. Notice this, 0 will always be one of the horizontal asymptotes. Always. Isn't that cool? So you always know what one of the horizontal asymptotes will be. The other one is C. So if you'll look at your model on page 1, you see how, in fact, would you look at the screen here real quick, please? Would you look at the screen? Do you see the letter C up top here in this logistic growth function? Whatever this number is, that's where your other horizontal asymptote is. That's so easy. Okay, so finding your horizontal asymptote, step 1 is really, really easy to do. Step 2, find the middle of the graph. Now, mathematicians, I'm just reading from your notes, top of page 2. Mathematicians call this the point of maximum growth. And you find the middle of the graph by using this formula, natural log of A over R, comma, C over 2. And that's an ordered pair, and that gives you the middle of the graph. So we'll do that in just a second. Step 3 says, enter the function into your calculator and make a table of values with putting step 2 in the middle. So whatever you got out for step 2, you're going to put that in the middle of your table of values. Step 4, sketch the graph. Don't forget to put your 2 horizontal asymptotes on the graph. So there we go. This is not too difficult, pretty simple. And so let me go ahead and get this graph pulled up here. And one thing I've been trying to do more of is actually, this video that I do, I can actually put your notes up here too. So let me quickly pull up. Here's the notes you're looking at right now in front of you, and we're going to sketch this function right here, okay? So let me quickly take this and pull this to Mimeo. There we go. And this is what we're going to graph. All right, so you've got your notes in front of you. We're on page 2, and we're going to graph this function. So here we go. Step 1 says find the 2 horizontal asymptotes. Okay, so we're going to have a horizontal asymptote at, now remember what step 1 said, you always have one at 0, and then the other horizontal asymptote is always going to be the number in the top of the fraction. So what number do we have in the top of the fraction? A 6. So my horizontal asymptotes are at 0 and 6. Now that's step 1, and it just doesn't get any easier than that. Okay. Now let's continue on to step 2. Step 2 says find the middle of the graph, and we're going, excuse me, and we're going to use this formula in your notes, which is this right here. I'll write that down for you. If you'll look at step 2 in your notes, it is natural log of A over R, comma, C over 2. All right, so using that formula, we are now going to find the middle value of the graph. So I think it would be very wise for us to quickly label some of these numbers up here. Well, if you'll look in your notes, 6 is always your C, and 1 is always going to be your A. Excuse me, that's incorrect, and I apologize. This number right here, 2, is always in front of the E. This number here is always going to be your A. Now here's where a lot of students get confused. Would you please listen to me and watch this? A lot of students think that R equals negative 0.5 because what's with the X? Negative 0.5. Well, be careful. Let's go back to your model. I want to show you something you really need to see. Okay. Look at your model. It's in your notes if you want to look. It's on the top of page number 1 in your notes. Look, do you see how it says negative and then R? Okay, what that means is you ignore the negative sign and you just go with what this number is here. Here's another way to say it. Here's the best way to say it. You ready for this? And Matthew, I know you're really big on taking side notes. And Chase, this would be a great time to take side notes, okay? Watch this carefully here. Let me back up and get rid of this. R really equals just 0.5. And here's the side note. Always change the sign of this number when you're looking for R. Now, you can pause the video, write that down, or just memorize it, whatever. But when you're trying to find R, like right here, A is 2. That's a positive sign. It's 2. C is 6. It's a positive 6. C is 6. You don't change anything. But with R, whatever the sign of this number is, always change the sign. That's what R will be. So if this was a positive 0.5, R would be a negative 0.5. If this is a negative 0.5, then R is a positive 0.5. So please, pause the video, make a side note, whatever you need to do, but please don't forget that, okay? All right, moving on. Well, we're going to take this ordered pair right here, this formula for an ordered pair, and we're going to make our simple substitutions. Natural log of A. Well, A is 2, so natural log of 2 over what? Isn't that an R right there? So over 0.5. So natural log of 2 over 0.5, and then comma, and then C over 2. We'll look up here. C is 6. So 6 over 2. Now you should know by now with your calculator how to take the natural log of 2. If you need some help with that, it's the left side of your calculator, third button from the bottom. Left side of the calculator, third button from the bottom. Go ahead and type in natural log of 2. And when you do that, let me get my screen cleared here. When you do that, you'll get 0.693, but then don't forget 0.693 over 0.5 or divided by 0.5. So if you type this whole thing into your calculator, the natural log of 2, then hit enter, you'll get 0.69314, etc. Divided by 0.5, you should end up with this decimal right here. I'm rounding, of course. You'll get 1.4, okay? I'm rounding. And then 6 over 2, of course, would be 3. 6 over 2 would be 3. So there you did step 2. Let's review. Step 1, find the two horizontal asymptotes. Well, 0 is always one of your horizontal asymptotes, and C, the number up top, is always your other horizontal asymptote. So that's pretty simple. Step 2, you take this formula, and you will have to memorize this. You take this formula and you substitute a number in for A, a number in for R, a number in for C, and then you simplify, and now you've got your middle value for your table of values. Don't forget, R, you always change the sign of this number when you're looking for R. Please don't forget that, okay? So continuing on, step 3 says find the middle value. We've done that. There it is. And now, or step 2 said that, excuse me. Now step 3 says to type this thing into your calculator. Oh, students, here's where it gets really tough, so take some really good notes, okay? We're going to type this into our calculator. So go ahead and turn your calculator on, hit the Y equals button, okay? Hit the Y equals button and clear out any functions you have in there. And here's what you type. Do this slowly, okay? First of all, you type the top, so hit 6. Then next, hit divide, so you'll see a slash appear. And then this is so important. You've got to tell the calculator this whole thing right here, this whole expression is your denominator, so you really need to put a parenthesis. So go ahead and put a parenthesis. And then go ahead and type in 1 plus 2. So go ahead and type in 1 plus 2. And then you should know where the E button is. It's right above your natural log button. So left side, third button from the bottom. You have to hit the second button and then the natural log. And this should pop up on your screen. If you typed it in correctly, it should be an E, popped up automatically, and then an arrow, and then a parentheses. If that's not what happened, you need to get some help from me, contact me, or keep practicing until you get it right. But again, it's the second function, so the blue button, the second button, and then the natural log button, and this should pop up. And then, of course, what is the exponent? They want you to type the exponent. Well, it's negative. Don't use minus. It's the negative button. So down at the bottom of your calculator, negative 0.5x, and then close your parentheses, and then close your parentheses again. So you're going to hit parentheses twice is what you're going to do. All right, and trust me, that'll work. Close your parentheses twice. Now, if you want to go ahead and hit graph just for the fun of it, you'll kind of see a sketch there, okay? Now go to table, and your table of values should have popped up. I'm going to change colors here. And so now for your table of values, remember, we found this middle value over here to the left, right here. I'm circling it in red. We found that middle value for a reason. It goes in the middle. That's why I call it the middle value. So right here in the middle, I'm going to put 1.4 and 3. Now, I don't care if you go up to 2 or down to 2. None of that matters to me. I'm going to go to the next nearest whole number. So I'm going to go to 2 and then 3. And then 1.4, I'm going to go, you could put a 1, I guess. I'm going to put a 0 to spread things out a little bit. If you put a 1 there, that's totally fine. It does not matter. The main thing I'm looking for is that middle value, making sure that's correct. Now, a -1, according to my calculator, is giving you out a negative 1.396. Negative 1 point, I'm going to go and put 1.4. We're going to round there. 0 gives you out a 2. All right. And 2 would give you out a 3.5 if you round correctly, 3.5. And then 3 would give you out a 4.1 if you round correctly. All right. So with that in mind, we are now going to take this ordered pair, or this, excuse me, this table of values, and we're going to graph this. All right, let's pull this up here. Here we go. And I'm not going for neatness of the year award. I'm going for speed. I'm going to quickly draw this, and now step 4 says sketch your graph, and step 4 also says don't forget to put your horizontal asymptotes on your graph. So while I'm drawing this, and I guess you're drawing one too in your notes there, if you'll look back at step 1, we already found the 2 horizontal asymptotes. One is at 0 and one is at 6. So you're going to want to put dotted lines at 0 and 6, just like this. I'm going to put a dotted line right here at 0 going across. That's called a horizontal asymptote. That's why it runs horizontally. And then 1, 2, 3, 4, 5, 6. We have another horizontal asymptote going across right here. Okay? There we go. We're looking really good. Now let's plot our points and sketch our graph, and we're done. The first order pair of my table of values, -1, -1.4, so about right there. The next one is 0, 2, so about right there. The next one is 1.4 up to 3, so about right there. And the next one would be 2 and over 3.5, so about right there. And the next one would be over 3 and up 4.1, so about right there. So remember, I know it looks like a straight line. Mr. Erhart, how do I just remember? Remember, first of all, look, students, I gave you a middle value for a reason. I'm highlighting it right now with my black pen. See that? So start at the middle, and you know it's going to go up like this, and then it's going to curve. That's why I teach you what the graph is supposed to look like before we even start. And now go this direction. Now it really should kind of dip down more like that, but again, I'm not that picky as a teacher as long as your asymptotes are in the right place and your table of values looks good. Your graph will be a little sketchy, for lack of a better word, okay? You're sketching it, so it's not supposed to be perfect. Okay, you did it. Now what you need to do is practice, 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 the dreaded word. So at least I'm being reasonable and not teaching for 40 minutes and then giving you homework. I'm stopping now, and I'm going to say to you, if you'll look at the bottom of your page number, the second page of your notes, you'll see that we're doing page 521, numbers 27 through 35 odd. So let's get after it. Please get to work. Your homework. I'm not, maybe your parents won't like this. I don't know, but I'm not collecting the homework. Somewhere along the way, you got to be mature and do things because you're supposed to, not because someone's always watching you. So you need to listen to the video. You need to do your homework. It is mandatory. And I guess on any day I could ask to see it. I'm not planning on doing that, but you need to do your homework, okay? So I've only given you 5. If each one takes 5 minutes, that's 25 minutes of homework. And I don't think each one will take 5 minutes, to be honest with you. All right? So here we go. You're welcome to stop the video, do them on your own, and check them. You're welcome to, I asked Michael, he kind of follows along, and then when he feels confident, he'll work ahead 2 or 3 steps and then play the video and kind of stay a couple steps ahead of it. So he's doing it but checking as he goes. You do it however you want to. You can watch the video, do it with me, or you can work ahead and then check it later. But let's start off with number 27. All right, number 27 looks like this in your book. Y equals 1 over 1 plus 6 e to the negative x. All right, are you ready? Let's get after it. Step 1 says, I'm going to go ahead and put a 1. I'm going to put S1 for step 1. Step 1 says to find the 2 horizontal asymptotes. Well, you always have a horizontal asymptote at 0. and the other horizontal asymptote will always be at whatever the top number is. In this case, your numerator is a 1, so your horizontal asymptote will be 1. Boy, that's easy. Step 2, if I remember correctly, said find the middle value using this formula right here. And here's the formula. It's natural log of a over r, comma, c over 2. So I'm going to go ahead and draw a line. I'm going to continue across. First of all, 6 is your a. I'm going to write that off to the side right over here. I'm going to say c equals 1. Do you see where I got that from? This number right here. C equals 1. A equals 6. Got that from right here. That's always your a. And r, now don't forget to change the sign. What number's in front of the x, even though you can't see it? A negative what? A negative 1. There's a negative 1 there. And for r, you always change the sign, so you're going to put a positive 1 right here. That's really, really important. Okay, so natural log of a, that's natural log of 6, over r, that's 1, comma, c over 2, that's 1 over 2. So let's go ahead and simplify these. We're going to go ahead and take the natural log of 6 and then divide that by 1. And if you do that correctly, you will get 1.8. I'm going to round to 1 decimal place. And of course, 1/2 is 0.5. So there we did step 2. We found our middle value. Now, step 3 says to type this function into your grapher. So I'm going to help you do it again. All right. First of all, hit the y equals button. And then, of course, clear out the other function you had in there. Hit y equals. And then you want to type in the numerator, which is 1. So put a 1. And then hit divide. So next you'll see a slash appear. Then put parentheses, because you're going to type this whole expression in for the denominator. Then hit 1 plus 6. And then you should know how to hit that E button. It's the second blue button and the natural log button. When you hit that, an E pops up with an arrow and one part of a parentheses. And then you would type in negative x and then close the parentheses twice. And there you've typed it in. And now you're ready for your table of values. So you've typed this whole thing in. And now let's go ahead and I think step 3 says type the function into your calculator and then write a T of V, a table of values. And of course we put our middle value from step 2 right in the middle. So 1.8 and 0.5. And so I'm going to very quickly here fill in my table of values and give your old math teacher just a second here. All right, and here we go. So I'm going to go to 3. I'm not going to go to 2. Now you probably put a 2 here, and that's fine. There's nothing wrong with that. I'm going to space my points out to get a little better picture of the graph. I'm going to put a 3 and then a 5. I guess I'll put a 4 because you probably put a 4 somewhere in your graph. It's just sometimes wise to spread out a little bit. And then going backwards, I will go to a 1 and then a 0. Now if you use different numbers, that's totally fine. For 0, I'm going to put 0.14. For 1, it's 0.31. For 3, we're looking at 0.77. And then 4 would be 0.90. So we can see it's going to be a really skinny graph, okay? Really, really skinny, which is okay. Nothing wrong with that. Everything's fine. All right, so let's go to a new page here. And let's see if we can't sketch our graph. And then we're moving on to the next one. 1 down and 4 to go. All right, very quickly. You don't have to be Mr. Joe Neatness here. We're just trying to get this thing sketched. There we go. Now it's going to be really hard to draw this. First of all, your horizontal asymptotes are at 0 and 1. So there's one of your dotted lines going through 0, and the other one's going to go through 1 right here. So you're really, I probably should have spread my tick marks out a little more, but I'm not going to worry about it now. It's going to be a really skinny S-shaped graph. Okay. Now, one point is at 0.1, so it's barely above 0, and the next one's 1.3, and the next one's over at like 3.7, and then 4.9. I think you get the idea. Remember what I taught you? Go to the middle value. Go to the middle value, which is right here, 1.8 and up 0.5. And just start there and sketch the curve. I really should have spread this out more, and I don't like what I've done here, but it's too late now. It looks like a straight line, but hopefully you get the idea. Next time I'll spread that out a little more. It's not a very good job, but hopefully you get the idea. The main thing is, do you have your asymptotes in the right place? Is your table of values correct? And next time we'll spread that out and make it look a little better. All right? Okay, let's continue on. I'm going to try to do something really quick here. Don't want to waste a lot of your time. There we go. And there we go. And there we go. And there we go. And there. We're going to use this to be a lot faster. Okay, good. We'll keep that up, and we will use that right now. Okay, good. And we'll use that from now on. Okay. Now let's go on to number 29. Number 29. All right, if you look in your book, number 29 looks like this right here. Y equals 5 over 1 plus e to the negative 10x. Negative 10x. Are you ready? Step 1 says list out the horizontal asymptotes. Your horizontal asymptotes would be at 0 and 5. We always have one at 0, and your top number is the other horizontal asymptote. Step 2 says find the middle value using this formula right here. Natural log, write that again, natural log of a over r, comma, c over 2. So let's come off to the side. We should know by now that c equals 5. I get that from this number right here. A equals 1, because remember, A is the number in front of the E. Now look at my pen, please. I'm going to write it in black for you to see it. There's no number in front of the E, so we understand there's really a 1 right there. Okay? So that's why we say A is 1. And now R, don't forget, you always change the sign for R. So the number in front of X is negative 10. I'm going to put a positive 10. So there we go. We're ready to roll. Natural log of A, that would be natural log of 1 all over R. R is 10, and then comma, and then c over 2. C is 5, so 5 over 2. Now break out your calculators. We're going to type in the natural log of 1, which is 0, and then divided by 10 is 0, so you should get 0. 0 over 10 is 0, and then 5 over 2 is 2.5. Okay? All right, let's go ahead then and go on to step 3. Step 3 says to type the function into your calculator, and then after you've typed it into your calculator, I'm going to go and put my middle point right here in the middle. All right, after you've typed it into your calculator, then go ahead and fill in your table of values. So here's how you should type it in. I'm going to change colors here. It should be y, hit the y equals button, and then you would hit a 5 first, and then divide, and then put a parentheses, and then 1 plus, and then E. You should know what that button is. When you hit the E button, an arrow pops up with part of a parentheses. Then you would type in negative 10x, and then close the parentheses and close it again. And that's what it should look like. Now if you've typed this in correctly, your table of values should be, well, we got a 0 here. I'm going to put a negative 1 and a negative 2, and then go to a 1 and a 2. Really doesn't matter what order you've put those in. Now, negative 2, okay, your grapher is going to say this. It's going to say 1e to the negative 8. Now, that's scientific notation, okay, students? And here's what that means. It means 1, but yet you're moving the decimal 8 places to the left, so it'd be like this. And you got to learn to read this. It'd be 1, 2, 3, 4, 5, 6, 7, 1. That's what it means. Okay? All right, let's take a look at your, I don't know why I did that. Hold on one second. There we go. Now, take a look in your graph for at negative 1. Negative 1, let's practice this again. Negative 1 says this. It says negative 1 gives you an output of 2.3. Then it says E negative 4. Now what that means is move the decimal 4 places to the left. Like the last one here, this one here, we move the decimal 8 places to the left. We're going to move this one 4 places. So let's move it 4 places. 1, 2, 3, 4. So it's 0.00023. So 0.00023. All right, and let's go on to 1. 1 gives you out 5. I'm going to round that to 5. And then 2 has an output of, 5 again. So I got to be very careful. I'm going to go ahead and put 4.9 repeating for number 1. and then for number 2 I'm going to put a 5. All right, so there we go. There's my table of values, and now I'm totally ready to sketch the graph. Let's pull all of this up here, and we're going to start using this from now on. In fact, I'm not even sure why I did that, so we're going to go back and go back and go back and go to here. So here's my table of values. I'm going to go ahead and sketch the graph. So the first thing I'm going to do is put my asymptotes on the graph, and my asymptotes were at 0 and 5, so I'm going to put 1 going across here. There we go. And then 1 horizontal asymptote at 5. There we go. And now let's plot our 5 points very quickly. The first one is -2 and -1. So -2 is at like 0.000000. It's way down here, like right there. And then -1 is at 0.00023. So like right here. It's really bottoming out quickly. Let's look at our middle value. Our middle value is at 2.5. So do you see how quickly it dropped? Remember how some S's will be stretched out, and then some will be like boom, just dropping straight down. I told you some would be narrow, wide, skinny, fat, etc. So there's these 3 ordered pairs, and then we have 1 goes to 4.9, which is right here, and then 2 goes to 5. So this thing, you can always start at your middle value when you sketch the graph. This thing's shooting up quickly, and then it curves, and then it just gets really, really close to the asymptote very quickly. Okay, it's really hard to draw, and again, if your table of values is sharp and your asymptotes are in the right place, I'm a pretty easy teacher to get along with, okay? But that's what the graph would look like. So there we go, 2 down, 3 to go, doing pretty good. All right, let's continue on. And we're going to actually use, let me go ahead and do something here. There we go. Everybody good with that graph? Because we're going to erase that in a little bit. So, all right, moving on to number 31. Number 31. If I'm going too fast, just pause the video and catch up, all right? Y equals 4 over 1 plus 3e to the -2x. I'm going to do something I haven't done before. While I'm already up here, I think that's actually -3x. Let me fix that. -3x. There. I'm going to go ahead and just quickly list out my C and my A and my R. So C equals 4 while I'm already up here. C equals 4 from this number here. A equals 3, and that's the number right here in front of E. And then R, don't forget you always change the sign. So what's in front of X? -3, so I'm going to put a +3. So there, that's already done. Okay, step 1. Let's list out the horizontal asymptotes. Well, we have horizontal asymptotes at 0 and 4. Always at 0, and the other one is the top number. Step 2, we use this formula right here, which is the natural log of A over R comma C over 2. So let's go ahead and fill that in. We have the natural log of 3 over R, which is 3, comma 4 over 2. Well, let's break out our handy-dandy calculators, and let's type in the natural log of 3. So natural log of 3 gives you 1.0986, then divided by 3. There's a 3 down here, so divided by 3. You should get 0.366 and comma, and then 4 over 2 is just 2. So there you did step 2. You found your middle value. Now step 3 says to type your function into your grapher. I'm going to quickly do that for you. You want to hit y equals, and then 4, then hit the division sign, and then put a parentheses, and then 1 plus 3, then hit your E button. So this pops up, this pops up, and this pops up. Then type in -3x, and then close your parentheses twice, and you're good to go. Now you're ready to go ahead and fill in your table of values. Don't forget to put in the middle your middle value, which is 0.366 and then 2. So if I have 0.366 right here, I'm going to jump a little bit. I'm going to spread it out a little bit. Well, I guess I'll go to 0, 0, and then -1. And then I would go to 1 and 2. Now, if you use different values, again, it's not a big deal. -1 would give you out a 0.06 or 0.07 around in there. 0 would give you out a 1. 1 has an output of 3.5. and 2 has an output of 3.9, almost 4. Okay, so using that table of values right here, I'm going to go ahead and highlight this a little better than what I've done there. Change the color. Okay, taking this table of values, we're going to go ahead now and we're going to graph this function. All right, so here we go. Okay, first of all, if you'll look back at step 1, your asymptotes are at 0 and 4. So I'm going to put a dotted line right here on 0 and then at 4. So there's my 2 asymptotes right here. All right, and now let's look at our table of values, negative 1.07. So negative 1, boy, we're really close to 0, 0.07, so right there. Probably even closer than that. 0 is 1, so 0 goes up to 1. Then here's my middle value. Middle value is 0.36 over to 2, so 0.36, then up to 2, so just about right here. And then we go to 1, 3.5, so over 1. Up 3.5, and then 2 is right up here. So remember, when you sketch the graph, always start at the middle value, so it shoots up pretty quickly on this one, then starts to curve, and then gets closer and closer. And then we come down here, this one's going to kind of curve like this. There we go. So that's the graph, okay? 3 down, 2 to go. 3 down, 2 to go. So here we go. All right, let's take a look at number 33. Here is the graph. Number 33 would be y equals 8 over 1 plus e to the negative 1.2 or 1.02x. So you'll find this in your book for number 33. And hey, while I'm here, I'm going to go ahead and write down my c and my a and my r. C equals 8. Get that from right here. A equals 1. I'm going to change colors and write that in. There's a 1 right here in front of the E, even though you can't see it. Okay, and then C, of course, is the number next to the X, only you always change the sign. So I'm going to put a positive 1.02. And now we are ready to roll. All right, step 1 says list out my horizontal asymptotes. I would have horizontal asymptotes at 0 and 8. Done with that. Moving on to step 2. Step 2 says find the middle value by using natural log of a over r, comma, c over 2. So very quickly then, I can do this. Natural log of a would be natural log of 1 over r, which is, oh, I called that a c up here, didn't I? Sorry about that. That's r. There we go. And r is 1.02, comma, and c is 8 over 2. Now, if you type in natural log of 1 and get out an answer and then hit divided by 1.02, you will get out 0, because the natural log of 1 is 0. And 0 divided by anything is going to be 0. And then 8 over 2 is 4. So there, we have found our middle value. Now, step 3 says to type in the function into your calculator, so it should look like this. You hit y equals, and then 8, then hit divided, then hit parentheses, and then 1 plus, and then the e button. And when you do that, an e should pop up with an arrow and a parentheses. And then you would write inside there negative, don't use the minus button, it's negative 1.02x, and then close the parentheses twice. All right? Now, if you've typed all this incorrectly, then you're ready for your table of values, which is the rest of step 3. And it should say to put your middle value right in the middle, so 0, 4. I'm going to go to 1 and 2, and then negative 1 and negative 2. And if you'll look in your grapher, let's see, a 2 would give you out a 7.1, so 2 is 7.1. 1 gives you out a 5.9, so 5.9. And negative 1 would be 2.1. And negative 2 has an output of 0.9 or 0.92. There we go. So using those, using this table of values, let's go ahead and graph our function. Let me come up here and hit eraser, erase all this stuff. And here we go. Let's go ahead and let's see, where were our asymptotes? 0 and 8. I'm not sure if I have 8 lines here. 4, 5, 6, 7. I'll have to do one a little higher. So here's 8 way up here. So here's one horizontal asymptote way up here at 8. which I don't quite have on my coordinate plane, which is fine, no big deal. And then down here, 0 on the x-axis. All right, so there we go. And with that in mind, let's go ahead and plot some ordered pairs here. First one is 2 over 2 upside. Actually, we're going to do something different. Let's start with the middle this time. Let's start with the middle. So the middle is 0, 4. So 0 up 4, right there. And then I'm going to continue on. 1 is 5.9, so 1 and then 5.9 goes up pretty quickly. And then 2 has an output of 7.1. So 2, 7.1, which is right there. So you can see, I'm going to go ahead and draw I'm going to sketch half the graph. It kind of shoots up quickly and then starts to curve right here. Okay, let's go ahead and plot the last couple ordered pairs. -1, 2.1. So -1, 2.1 would be right there. And then we would have -2, 0.92. So -2 and then 0.92. So then the rest of the graph will come up like this, hit here, and there's the middle value right there. And there's the graph. Not too bad. Actually looks pretty good. All right. One of those rare moments I actually drew something decent. Last one, number 35, and we are finally finished. Number 35. Y equals 6 over. Y equals 6 over 1 plus 0.8 e to the negative 2x. Well, let's fly. Here we go. C equals 6. A equals 0.8. R equals positive 2. Positive 2. All right, so we're going to go ahead and hit step 1. Step 1, I have horizontal. I'm going to go really fast on this. We've done 5 of them now, 1 in your notes and 4 for homework. So horizontal asymptote should be at 0 and 6. Step 2, we have our formula, natural log of A. That's natural log of 0.8 over R. R is 2, comma C over 2. That's 6 over 2. All right, let's go ahead and type this into our calculator. If you hit the natural log of 8, the natural log of 8 is 2.07944, then divided by 2. Because there is a 2 in the denominator, you will get 1.04. So 1.04, comma, and then 3, because 6 over 2 is 3. So very good. Now we're going to type the function into your grapher, and it should be hit the y equals button, then hit 6, and then divided by, then parentheses, then 1 plus point, not 8, but 0.8, then hit the E button, and when you do, this pops up, and this pops up, and this pops up, and you would type in negative 2x. Don't use the minus sign, it's negative, and then parentheses, parentheses. Okay, and by the way, I hate this because you probably did not continue on the video, but this is a mistake right here, and I apologize. I can't redo the whole video, for one mistake, but I hit natural log of 8 back here instead of natural log of 0.8. So really, what we should have here is a negative, let's see here, negative point, let me clear my screen here, negative 0.111, comma 3. So I did that wrong, and I do apologize, but nothing I can do about it now except tell you that I made a mistake. So let's continue on. So hopefully you continued listening to the video and didn't get all upset over missing that. But your middle value should be negative 0.11, and your y would be a 3. So let's go ahead and fill the rest in. I would probably go to negative 1 and then negative 2. I would probably not go to 0 here next. That's too close to 0. I mean, if you did, that's fine. I would probably go to 1 and then 2. Okay, let's see what we have here in our table of values. Negative 2 is 0.13. Negative 1 is 0.86. 1 would be 5.4. And the value of 2 would have an output of 5.9. 5.9, okay? So with that in mind, let's go ahead and let me grab my eraser real quick, and let's erase this graph. Let's graph our last one, and we're finally done. So good deal. Get this over with. All right, we have horizontal asymptotes at 0 and 6. So I'm going to go ahead and use blue this time. And there's one dotted line at 6 right there, and then another dotted line at 0 going across. So there we go. And there we go. Now, table of values, my first ordered pair is negative 2.13. So negative 2.13, that would be just about right there. And the next would be negative 1 is 0.86, so negative 1 and 0.86. And the middle value would be negative 0.1, negative 0.1, all the way up to 3. So just about right there. I'm going to go ahead and sketch part of this graph. I'm going to stop right at the middle value right there. So you can see part of the graph taking shape here. All right. Now let's go ahead and plot our last two order pairs. 1, 5.4. So 1, 5.4 would be about right there. And then the other ordered pair would be 2, 5.9. So over 2 and then all the way up to here. So then it looks like it continues to go up and then curve and then curve. And you know what? We are finally done. So there we go. You have learned today, much to your excitement, I'm sure, how to graph logistic growth functions. All right. Stay tuned for a video tomorrow on Tuesday.